Good morning students. Today we are going to start with the topic motion in a plane with constant acceleration. Earlier we have done the motion in a straight line. Now we will do motion in a plane with constant acceleration. In this part we will find two things. One, the velocity vector, and second, the position vector in a plane for a body which is moving with constant acceleration. So first we will consider a body which starts from time t is equal to 0, and at time t is equal to 0 the velocity of the body is v0, and at time t is equal to t second the velocity of the body is v vector. So the average acceleration of the body is v0 minus v upon t minus 0. As acceleration का फॉर्मूला क्या होता है? चेंज इन वेलोसिटी अपॉन चेंज इन टाइम. तो चेंज इन वेलोसिटी क्या होगा? फाइनल वेलोसिटी माइनस इनिशियल वेलोसिटी, दैट इज v नॉट वेक्टर माइनस v वेक्टर, एंड टाइम इज t minus 0. So from this equation the value of v vector comes out to be v naught plus at. Now we have to write these in terms of the rectangular components, that is in terms of I cap and j cap, where I cap is the unit vector along x-axis and j cap is the unit vector along y-axis. So v vector can be written as v naught x cap plus vy j cap, and v naught vector can be written as v naught I cap plus v naught y j cap, and the acceleration can be written as ax I cap plus ay j cap into t. Now first of all, on the right hand side we will separate the components of I cap and j cap. So we get vx I cap plus vy j cap is equal to v naught x plus ax into t I cap plus v naught y plus ay t into j cap. Now we will equate the coefficient of I cap and j cap on both sides. We get vx is equal to v naught x plus axt, and vy is equal to v naught y into ayt. So this is the expression for the velocity. Here vx and vy are the final velocity, that is the velocity at time t. v naught x and v naught y are the velocities at time initial time, that is at t is equal to 0, and ax and ay are the acceleration in x direction and y direction respectively. Because here we are not taking a single straight line motion. Here we are talking about the motion in a plane. So in a plane we consider axis like x-axis and y-axis. Next we have to calculate the position vector. For position vector we know the value of displacement is average velocity into time. तो displacement हमारा क्या होगा? यहाँ पे जो एक बॉडी है उसका जो फाइनल पोजीशन वेक्टर है वो r वेक्टर है और इनिशियल पोजीशन वेक्टर r नॉट वेक्टर है. सो द डिस्प्लेसमेंट इज r वेक्टर माइनस r नॉट वेक्टर. एवरेज वेलोसिटी क्या आएगी? v नॉट वेक्टर प्लस v वेक्टर अपॉन 2 इंटू टी. इसमें हम v वेक्टर की वैल्यू पुट कर देंगे बिकॉज वी नीड द टर्म एक्सेलरेशन. वी हैव v नॉट वेक्टर प्लस a वेक्टर इंटू टी. आफ्टर सॉल्विंग इट वी गेट r vector is equal to r naught vector plus v naught vector into t plus half a vector into t square. Now we will substitute their rectangular components. After substituting the rectangular components, we will compile the terms containing I cap and j cap on right hand side, and then we will equate the coefficient of I cap and j cap on both sides. We get x is equal to x naught plus v naught x plus half axt square, and y is equal to y naught plus v naught y plus half ayt square, where x is the displacement in the x-axis, y is the displacement in the y-axis, x naught and y naught are the initial point जिस point से motion start हुआ था. v naught x is velocity in x axis, v naught y is velocity in y axis, ax is acceleration along x axis and ay is the acceleration along the y axis. Next we are going to study the projectile motion. What is the projectile motion? Projectile motion means once a body is projected with some initial velocity, then after being projected with some initial velocity, the body moves under the influence of the gravity alone without being propelled by any engine. मीन्स अगर एक बार हमने बॉडी को कुछ इनिशियल वेलोसिटी देके प्रोजेक्ट कर दिया, उसके बाद जो बॉडी है इट मूव्स अंडर द इन्फ्लुएंस ऑफ ग्रेविटी अलोन. इट डज नॉट नीड एनी इंजन और एनी एक्सटर्नल एजेंट टू ड्राइव द बॉडी. such type of motion is known as projectile motion. The example of projectile motion are javelin throw or bullet fired. Whenever you fire a bullet from a gun, तो जो हमारी velocity से bullet fire होती है, after being fired, it goes under the influence of gravity alone. उसके साथ कोई इंजन या कोई एक्सटर्नल एजेंट नहीं होता जो उस बुलेट को लेके जाता है आगे. इट ओनली मूव्स अंडर द इन्फ्लुएंस ऑफ द ग्रेविटी. सो the motion followed by the bullet fired from the gun is an example of a projectile motion. अब projectile motion में we will study two types of projectile motion. One is projectile given horizontal projection and second is projectile projected with an angle theta with the horizontal. So first we will do projectile given horizontal projection. You can see in this figure, here we are having a particle which is given a initial velocity u, and after being projected it moves under the influence of the gravity. अब हमने जो थ्रो किया है उस बॉडी को with velocity u from a height h from the ground. यहाँ पे जो कैपिटल r है, it is the range, that is the total distance covered by the body on the ground, that is known as the range of the projectile. Next, जब भी हम किसी बॉडी को प्रोजेक्ट करते हैं with some initial velocity u in horizontal direction, तो जो बॉडी है it goes two motions simultaneously. एक तो it will move in the horizontal direction due to the velocity, initial velocity u, and second it will move in the vertical direction, that is vertically downward under the influence of acceleration due to gravity small g. Now first of all we will study the trajectory. Trajectory क्या है? It is the path which is being followed by the object which is being projected. So for that first we will consider the horizontal displacement. The horizontal displacement will be equal to x is equal to ut. From here we will find the value of t, which is equal to x upon u. Then we will see the vertical displacement या vertical distance covered. It is equal to vertical distance कितना है हमारा h, और vertical direction में हमारी initially कोई velocity नहीं थी. जो initial velocity u थी it was only in the horizontal direction. So we have s is equal to ut plus half at square. a की जगह हमारे पास क्या आ जाएगा g. अब body is moving downward, so a value of acceleration due to gravity is positive. So we have y is equal to half g x upon u whole square. By rearranging we will get y is equal to half g upon u square into x square. Half g upon u square is constant. So we have equation as y is equal to kx square, and this is the equation of parabola. So the trajectory of an object which is being projected with some initial velocity u in horizontal direction is a parabola. Next we have time of flight. Time of flight is the total time for which the body remains in flight. Means the total time starting from O till it touch the ground. For it we will use the equation S is equal to UT plus half AT square. U is 0. Total vertical जो हमारा distance है that is H. So we get the time of light as T is equal to under root 2H upon G. Next we have horizontal range. What is horizontal range? Horizontal range is the total distance which is covered by the body which is being projected on the ground. Horizontal range, it is represented by capital R, which is equal to horizontal velocity into time of flight, which is equal to U into under root of 2H upon G. Next we have velocity at any instant. Velocity at any instant means जो भी projectile है किसी भी instant of time पे जो उसकी instantaneous velocity है, that is represented by V, which is equal to under root of Vx square plus Vy square. Vx is the horizontal velocity, Vy is the vertical velocity. Horizontal velocity हमारी किसके equal है? U. For vertical velocity we will apply first equation of motion, that is V is equal to U plus AT. Initially vertical में हमारे पास initial velocity 0 है, A की value is G, so we have Vy is equal to Gt. So we get the instantaneous velocity as under root of U square plus Gt whole square. Okay students, that's all for today.